Hello everyone, welcome back to my channel. We are going to talk about decision tree, one of the most interpretable and beginner friendly machine learning algorithm. Many machine learning models give great accuracy, but it's hard to understand how they make decisions. Decision trees are different. They work very similar to human decision making step by step. So a decision tree is a supervised machine learning algorithm used for both classification and regression problem. It works by breaking a complex decision into a series of simple yes or no questions based on the feature of data set. Visually, it looks like a upside down tree. Each internal node represents a decision. Each branch represents an outcome. Each leaf node represents the final prediction. Because of this structure, decision trees are very easy to understand and explain even to non technical people. A decision tree has four main concepts: root node, decision nodes, branches, and leaf node. Now,
Now,
root
root
node.
node.
This
This
is
is
the
the
top
top
node
node
where
where
the
the
data
data
set
set
is
is
first
first
split.
split.
Decision node. The node apply condition like is age greater than 30 or etc. Branches. Branches represent the result of decision yes or no, and leaf nodes. These are final nodes where the prediction made. Each path from root to leaf form a decision rule. The decision algorithm works by selecting best feature at step to split the data. The goal is to create subsets that are as pure as possible, meaning most data points belong to the same class. The process may look like: start with the full data set, choose the best feature for splitting, split the data, repeat the process for each subset, stop when the condition is met. The key question is, how do we decide which feature is the best? That's where splitting criteria come in. Number 1, gene impurity. Gene impurity measures how often a randomly chosen data point would be misclassified. Gini value is equal to 0 means perfect purity, lower Gini is better. This metric is used by the CARET algorithm, which is very popular in practice. Number 2 is entropy. Entropy measures the uncertainty or randomness in the data. Entropy is equal to 0 means no certainty. Higher entropy means more or higher mixed classes. Information gain. Information gain tell us how uncertainty reduced after split. Higher information gains means a better split. This is used in algorithm like ID3 and C45. There are two main type of decision tree: classification tree, used when the target variable is categorical. Example: spam versus not spam, yes versus no, disease versus healthy, and etc. Regression tree. Now use when the target variable is continuous. Example: house price prediction, sale forecasting. Instead of class label, leaf nodes store numerical values. Some commonly used decision tree algorithm are ID3, uses information gain, works with categorical data. C45. Now the second is C45, improved version of ID3. It's supposed to support continuous data. Now last is CARET, uses DNA impurity, supports both classification and regression. Among these, CART is the most widely used in real world application. Overlifting the decision tree. One major problem with decision tree is overfitting. If a tree becomes too deep, it starts memorizing the training data instead of the learning general patterns. Reasons There are few reasons for overfitting include too many splits, no limit on the tree depth, noisy data. To solve this problem, we use pruning. Pruning in decision tree. Pruning helps to reduce overfitting by removing unnecessary branches. These are two types. Pre-pruning, it stops the tree early by setting limits. Post pruning, build a full tree, then remove branches. It removes especially weak branches. Pruning improves generalization and model performance on new data. For classification, common metrics are accuracy, precision, recall, F1 score. For regression, we use mean square error, mean absolute error, or R squared. Choosing the right metric depends on the problem you are solving. Now, the advantages of decision tree is that it is easy to understand and interpret the minimal data processing, handle numerical and categorical data. It captures non-linear relationship, and there are limitation of that too. It is very prone to overfitting, sensitive to small data changes, less accurate than ensembling methods. That's why decision tree are often combined to ensembles. Few real world application of decision tree is like healthcare. Diagnosis Decision tree are used in disease diagnosis and healthcare, finance for credit approval, and etc. They are especially useful when explainability is important. Decision tree are also used in feature selection, rule based system, explainable AI as base model for random forest and gradient boosting. Understanding decision tree makes advanced algorithm much easier to learn. To summarize this, decision tree are powerful, simple, and highly interpretable machine learning model. While they have limitation like overfitting, these can be handled using pruning and assembling method. Mastering decision tree gives you a strong foundation for advanced machine learning.